Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0717 indicates that there is no signal input from the input shaft, main shaft speed sensor in the Honda CRV models from 2011 to 2016. This sensor plays a crucial role in the vehicle's transmission system by providing information regarding the rotational speed of the transmission's input shaft to the powertrain control module, PCM. A malfunction could lead to improper transmission functioning, resulting in shifts that are not optimized for performance or fuel efficiency. It is important to note that this code is related to an electrical circuit fault, rather than a mechanical failure within the transmission itself. Troubleshooting must be approached systematically to isolate the electrical issue and ensure the proper functioning of the sensor. Before beginning, always record freeze frame data and any relevant onboard diagnostics (OBD) snapshots for reference. The DTC P0717 indicates an electrical circuit problem with the input shaft, main shaft speed sensor. This component is vital for measuring the rotational speed of the main shaft, which is essential for the powertrain control module, PCM, to manage the transmission effectively. The sensor is specifically located within the transmission assembly, where it can directly monitor the input shaft's speed. If the PCM does not receive a signal from this sensor, it can lead to numerous transmission issues, such as erratic shifting or loss of power. Understanding the role and placement of this sensor is crucial for accurate diagnosis and repair. The fact that this DTC cannot be attributed to mechanical issues underscores the importance of thorough electrical troubleshooting. Several potential causes can lead to the triggering of DTC P0717 in a Honda CRV. First, an open circuit in the wiring, specifically along the wiring harness connected to the input shaft speed sensor, could prevent the PCM from receiving necessary speed data. Similarly, a short circuit could create an erroneous signal or fail to deliver the correct signal altogether. A malfunctioning input shaft sensor itself could directly lead to this code if it is not able to output the required signals to the PCM. Lastly, a failing powertrain control module, PCM, might not interpret signals correctly, even if the wiring and sensor are functioning as they should. Each of these causes necessitates a thorough inspection to identify the root issue accurately. The symptoms associated with DTC P0717 can significantly affect vehicle performance. Drivers may experience erratic transmission shifts, leading to a less than smooth driving experience. Additionally, there could be a noticeable loss of power while accelerating, as the transmission may not be able to select the proper gear based on the input shaft speed data received, or lack thereof. Such symptoms often correlate with decreased fuel efficiency, as an inability to shift properly can lead to the engine working harder than necessary. It's essential to monitor for these signs if a P0717 code is present, as they can indicate an underlying issue that could worsen over time if left unaddressed. The first troubleshooting step for DTC P0717 involves verifying the problem through initial checks. Begin by turning the ignition switch to the on position without starting the engine. Next, you will need to clear the DTC using the Honda Diagnostic System, HDS, which prepares the system to monitor for new data without being influenced by past codes. After clearing the DTC, raise the vehicle securely so that the front wheels can rotate freely. Start the engine and disable the Vehicle Stability Assist (VSA) by pressing the VSA off button. It is critical to run the vehicle with the shift lever in D while maintaining speeds above 12 miles per hour, 20 kilometers per hour. Monitor and compare the input shaft, main shaft speed, and output shaft, counter shaft speed using the HDS. If both speeds are consistent, this indicates that the system is operating effectively at that moment. However, if the speeds are not equal, the failure is present, and you should proceed to the next troubleshooting step. In this second troubleshooting step, we will conduct an open wire check of the VCC2 line. Begin by turning the ignition switch to the lock 0 position to ensure safety. Then, proceed to disconnect the input shaft main shaft speed sensor 3P connector, which allows you to isolate the sensor from the circuit for testing. After the connector is disconnected, turn the ignition switch back to the on-2 position. With the sensor disconnected, use a multimeter to measure the voltage between the designated test points. Test point 1 is located at pin number 3 of the 3P connector, generally identified by a pink wire PNK, and test point 2 is body ground. You should expect to find about 5 volts between these points. If this voltage is present, it indicates that the VCC2 wire is functioning correctly, and you can proceed to the next step. However, if the voltage is absent, it suggests an open circuit in the VCC2 wire leading to the powertrain control module, PCM, which will require repair. The third step in the troubleshooting process requires further voltage measurements focused on the NM line. After verifying the VCC2 line, the next phase involves testing for voltage in the NM circuit. With the ignition in the on-2 position, disconnect the input shaft main shaft speed sensor 3P connector again. Measure the voltage between the second test point at pin number 2 of the 3P connector, which is identified by a white wire or WHT, and the body ground. You are looking for an expected voltage of approximately 5 volts. If this voltage measurement is positive, it confirms that the circuit is functioning properly, and you will proceed to the next troubleshooting step. If you do not get the expected voltage in this instance, it indicates that there is likely an issue within the NM wire leading back to the PCM, which will necessitate further inspection to locate and repair the fault. The fourth troubleshooting step focuses on checking for continuity in the SG2 line. Ensure that the ignition switch is in the lock 0 position for safe handling. Disconnect the input shaft, main shaft, speed sensor, 3P connector once more. Use a multimeter to check for continuity between test point 1, which corresponds to pin number 1 of the 3P connector and is marked by a gray wire, GRY, and test point 2, which is body ground. Continuity is essential to verify that there are no breaks in the SG2 circuit. If continuity is detected, this indicates that the SG2 wire is functioning properly, prompting you to replace the input shaft, main shaft speed sensor itself as a likely source of the issue. If continuity is not found, it suggests that there is an open circuit in the SG2 wire that must be repaired before continuing. In this fifth step of troubleshooting, we will identify potential shorts in the NM wire circuit. Initially, ensure that the ignition switch is in the lock 0 position for safety. Use the Honda Diagnostic System, HDS, to jump the SCS line, which prepares the system for testing. Next, disconnect the PCM connector B49P to isolate the PCM from the circuit. With the ignition still at lock 0, measure for continuity between the NM line at test point 1, pin number 2 of the 3P connector, and body ground at test point 2. If there is continuity, it indicates a short to the ground in the NM wire between the sensor and the PCM, which will require immediate repair. Conversely, if there is no continuity, it indicates that the NM wire is not shorted, but may still be open and will necessitate further examination to conduct appropriate repairs before proceeding with the verification steps. After carrying out the necessary repairs based on the previous troubleshooting steps for DTC P0717, it is critical to verify that the issue has been successfully resolved. Begin by carefully reconnecting all connectors that were disconnected during the troubleshooting process to ensure continuity in the electrical system. Next, turn the ignition switch to the on-to position without starting the engine, turning your attention to the Honda Diagnostic System, HDS, to clear the previously diagnosed DTC codes from the system. Once cleared, start the engine and disable the Vehicle Stability Assist, VSA, again. Conduct a test drive with the shift lever in D, maintaining speeds over 12 miles per hour, 20 kilometers per hour. Finally, you must repeat the process of comparing the input shaft, main shaft speed, with the output shaft, countershaft speed, using the HDS. If the speeds are consistent, it verifies that the repairs were successful, implying that DTC P0717 was resolved properly. If discrepancies persist, further action may be required. While this troubleshooting focuses on resolving DTC P0717, implementing preventive maintenance can help reduce the risk of similar issues in the future. Regularly inspect wiring and connectors related to the input shaft, main shaft, speed sensor for signs of wear, damage, or corrosion. Ensuring that the wiring is protected from environmental hazards can mitigate risks associated with shorts or opens in the circuit. Keeping connectors clean and free from debris can also help ensure reliable performance of the electrical connections. Furthermore, consider periodic diagnostic checks using the Honda Diagnostic System, HDS, to monitor for any early signs of issues. Taking these steps can contribute to overall vehicle reliability, particularly concerning transmission performance. In conclusion, the DTC P0717 presents a significant electrical issue involving the input shaft, main shaft speed sensor in Honda CRV models from 2011 to 2016. Understanding that this code represents an electrical problem rather than a mechanical failure is essential for effective troubleshooting. The systematic approach involves verifying the signal input, checking wiring integrity, and testing the sensor itself to identify any faults. By following each troubleshooting step, a technician can accurately diagnose the issue, perform necessary repairs, and verify the resolution of the DTC. Additionally, engaging in preventive maintenance will help ensure optimal performance and reliability in the vehicle's transmission system. It's crucial to stay vigilant in monitoring for related symptoms that could signal recurring issues. Please like and subscribe to the channel. See you next time.